Hello students, let us start with topic number 4.3, motion in a magnetic field. Now here we have to consider a charged particle which is moving inside the magnetic field. Students, in figure you can see there is a magnetic field shown by cross. This cross are nothing but the magnetic field, and the meaning of cross means the magnetic field is moving inside the plane normally. Now when the charged particle having velocity, you can see here a charged particle q, it has a velocity. When it enters the magnetic field, the force acts on it. A moving charge, when it enters the magnetic field, force acts on it, and that force is given by F is equal to QVB, and this we have studied earlier. Actually in vector form the force F is equal to Q V cross B, but here given that the charged particle, its velocity is perpendicular to the magnetic field, it enters perpendicular to the magnetic field, and so when we remove this cross product, we know that there will be a sine theta, and as V and B they are perpendicular to each other, sine 90 is equal to 1, and so we have simply considered this magnitude. So force acting on the charged particle is given by QVB, and so due to that force what happens, as the velocity is in this direction, magnetic field at this point is normally moving inside the plane, and so using right hand rule we get the force which is in this direction, that is perpendicular to both velocity as well as magnetic field. So in general the path of this motion of charged particle will be circular. Whenever the particle is moving at any place, the force acts towards the center, and velocity will be always tangent to the circular part or circular curve. So you can see here in figure the charged particle, different positions are shown, but at each and every position the velocity is tangent to the curved path and force is directed towards the center. This is the center of this curved part. So students, I hope you understood this. Always remember, whenever a charged particle having velocity enters the magnetic field which is perpendicular to the velocity, then that charged particle will move in a circular path. Students, here one thing is important to note, that the direction of velocity you can see at each and every point, the direction of the velocity changes, but the magnitude of velocity does not change. If I say at this point, if the magnitude of the velocity is 60 meter per second, then even at this point also the magnitude of the velocity will be 60 only, but direction is different. So at each and every different points the direction of the velocity is different, but its magnitude remains same, and that charged particle will move in a circular path with some radius. Here the radius is r, because if there is a circular path then that circle will have a radius, and force is always towards the center, and we know that velocity changes at each and every point, and change in velocity means it is, we know that change in velocity with respect to time is nothing but it is acceleration. So here the motion is accelerated motion, and that's why whenever there is an acceleration there is a force, and force is towards the center, and so the acceleration is also towards center. So now students, it is clear that velocity is also perpendicular to the force, and this both, that is V and F, they are perpendicular to magnetic field. That is velocity, magnetic field and force, they are mutually perpendicular. Now as this force is acting towards the center, every time this force acts towards the center, and so that force is called the centripetal force. Remember students, always when there is a uniform circular motion, the force acting towards the center is called a centripetal force. So here this centripetal force is nothing but it is a force on a charged particle having velocity in a magnetic field. And so now let us start the mathematical steps related to this. So now it is clear that this centripetal force is provided by the magnetic force, and we know the formula for the centripetal force. It is always given by mv square by r, and this you have studied in 11th standard in uniform circular motion. And Fb is QVB. Making subject R, we get R is equal to mv upon QB. Students, here V will cancel, so only one V will remain, and so making this R subject, we will get this equation. Let us give this equation number 2. Here this R is nothing but it is radius of this circular path. Equation number 1 is this magnetic force. Now when the particle is moving in a circular path, its velocity can be given in terms of angular frequency, and we know that it is given by V is equal to R omega. Again we have studied in uniform circular motion. So now putting this value of V, which is R omega, here in equation number 2, we get R is equal to m value of V upon QB. Now making subject omega, if we make the subject omega, we will get omega is equal to QB upon m. Here R will cancel, so here remain only 1, and so when you make the subject omega, QB will move in the numerator and m will be in the denominator. Also we know that omega is equal to 2 pi nu. Students, remember this symbol, it is nu. Sometimes this symbol, in place of this symbol we use f also, small f, but as in your textbook the symbol for this frequency is given as nu, so we will use nu only and not the f. So omega is equal to 2 pi nu, where nu is nothing but it is a frequency of rotation. Omega is angular frequency and nu is simply frequency. So putting omega is equal to 2 pi nu and making the subject nu, will get this equation also. So I hope you understand about this theory also. It is quite simple theory. Now students, in this case we have seen that the charged particle is moving perpendicular to the magnetic field, but here one condition is given. If the velocity and B magnetic field, if they are not perpendicular to each other, then what will happen? We will get one component of velocity which is parallel to the magnetic field. Students, we know that while dealing with the vectors, if I say this is x-axis, this is y-axis, and if any vector is along this direction, suppose this vector is vector A, then if this vector is along this direction, which is neither along x-axis nor along y-axis, and if the angle made by this vector A with x-axis is theta, then we get two components of vector A. One along the x-axis called x component of A, or we can say it is a parallel component also because horizontal direction, and the other component is y component. We can call that component as perpendicular component also. So here also, if the velocity is not perpendicular to B, then we get two components of the velocity, one parallel to the magnetic field and other perpendicular to the magnetic field. And what happens due to this reason? This component will tend to move the particle in a helical motion. Now it is not exact circular motion because charged particle enters in a magnetic field which is not exactly perpendicular to it, and so in general the motion will be helical motion. Here in helical motion, you can see here I have shown in figure that here this is a velocity and this is the parallel component along the magnetic field, and due to this component this particle will have its velocity towards the magnetic field also. So it will go on rotating like this, as well as it will move towards the magnetic field, that is in the direction of magnetic field. Here between these two curves, that is one circle, and then when the other circle starts, that distance is called the pitch, denoted by small p. So what is pitch? P, it is the distance moved along the magnetic field. It is distance towards the magnetic field in one rotation, that is after completing one rotation it has moved some distance. The charged particle has moved some distance towards the magnetic field, and that distance is called the pitch. Now due to this there is some velocity along the magnetic field, and that velocity is velocity parallel to the magnetic field, V parallel. And we know that when one complete rotation is there, that time is known as periodic time. And so distance, that is pitch, this distance is velocity into time. So velocity is parallel velocity along magnetic field and time is periodic time. So V parallel into T will give us the distance of pitch. Students, here for this equation, let me show you that we know that V now students, for this equation, let me show you, we know that V is equal to distance upon time, and so distance is V into T. So here also we have applied the same thing. Here distance is pitch and velocity is parallel velocity which is along magnetic field, and for one complete rotation the time taken is considered as a periodic time. And so we have taken P is equal to V parallel into T. Now periodic time T. So we already obtained the equation. Here you can see frequency nu is equal to QB upon 2 pi m, but this frequency nu is equal to inverse of periodic time. Frequency is inverse of periodic time, and so what is T? If frequency is this, then T will be inverse of this term, that is 2 pi m upon QB. So here also we are going to put T is equal to 2 pi m upon QB. So this is the value of T and V parallel as it is. So I hope you understand about the distance of pitch or the length of the pitch. So this type of motion is obtained, which is nothing but it is helical motion. Now students, you can see here the helical motion of this charge particle. Here a positive charge particle is shown. It enters the magnetic field, but its velocity is not exactly perpendicular to the magnetic field, and so its path becomes helical. Now students, helical motion is there. So if we consider from this point to here, then it will be nothing but the radius of this helix. So even a helix has a radius, because in general it is also a circular like path. Now students, even in this image also you can see the helical motion of an electron. Electron is also a charged particle like proton. So here you can see the pitch denoted by x. This distance x is nothing but the pitch of this helical path of electron. Now students, this principle of motion of a charged particle in a magnetic field is used practically in cyclotron. Now what is cyclotron? That we will study in our next topic. Now our next topic is topic number 4.4, motion in combined electric and magnetic fields. Students, we have already studied about this concept, that when the charged particle having velocity is moving in both electric field and magnetic field, then both the force acts on it, that is electric force as well as magnetic force will act on that moving charge, and the resultant force is given by this equation. F is equal to Fe plus Fb in vector form. And finally we get this equation. We obtained this in our earlier lecture. Now here in figure you can see the three-dimensional coordinate system is shown, that is x-axis, y-axis and z-axis. A charged particle is shown at the origin. Its velocity is along the x-axis, and so we can write V is equal to V I cap. Here this V is the magnitude of the velocity and this I shows the direction. as this charged particle is moving in positive x direction, its direction is given by this unit vector I. Similarly, you can see the electric field, it is along the y-axis, and so you can see here E, vector E is nothing but its magnitude, that is E, and direction is given by j cap because it is along the positive y direction. Similarly, along the z axis you can see there is a magnetic field in that z direction. So B, vector B is its magnitude and its direction. Z direction is represented by unit vector k cap. So here this velocity, electric field and magnetic field are shown. So the force acting on this charged particle which is at the origin at some instant, so its electric force will be always in the direction of electric field. The electric force on a charged particle which is positive charged particle will be along the direction of electric field, and so here it is given that Fe is equal to Q into E. But what is E? E is nothing but it is E j cap. So here we have kept that. Similarly, magnetic force Fb, we know that the magnetic force is perpendicular to both velocity as well as magnetic field, and its direction is given by right hand thumb rule or right hand screw rule. So here if you use the right hand screw rule, then you will get the direction of the magnetic field will be towards negative y direction. You can see this force will be towards the negative y direction, and that's why here Fb is Q into V into B, that is shown here, and we know that I cap cross k cap will give you minus j cap. So here the direction is along negative y direction, so j and minus sign is kept here, and we have given these equations, that is electric force as equation number 1 and magnetic force as equation number 2. Now students, if we select these values of electric field, charge or the magnetic field or velocity in such a way, that means whatever the physical quantities you can see here, if we select these physical quantities in such a way that this electric force and magnetic force becomes equal. Remember students, if these two force becomes equal, then this charged particle will not move in upward direction or in the downward direction. That means it will not have its motion along the y-axis, because both the forces are equal in magnitude and opposite in direction. So in that case, if the resultant force acting is 0, this resultant force acting is 0 because these two forces Fe and Fb are mutually in opposite direction and their magnitudes are same. So in that case, what happens? The velocity will remain constant. There will not be any acceleration of the charged particle. So now we will consider that condition that both the forces are equal in magnitude and opposite in direction, and so resultant force is 0 on the charged particle. And so considering this concept, we know that Fe is Q into E and Fb is QVB. Both the side QQ will cancel each other, and if we make the subject V, that is velocity, then V will be equal to E by B. So we get the formula for the velocity in this special condition when both these forces are equal. Students, in this condition when both these forces becomes equal, in that case we obtain this velocity, and so this condition is called the velocity selector. Remember what it is called? Velocity selector. And this concept is used to select charged particles of particular velocity out of the beam containing the charges moving with different speeds. Means, suppose if there is a beam of charged particle, there are different charged particles in this beam with different velocities. But if we want those charged particles only with particular velocity to come out of the beam, that means if we want only those charged particles which are having this velocity given by E by B, only those charged particles will come out of the beam undeflected. Means the other charged particles with different velocity will be deflected in different direction, but only those charged particles can come out which has the velocity V equal to E by B. Students, this method was employed by J.J. Thomson in 1897 to measure the ratio of charge and mass, that is ratio E by m of electron. Then this principle is also employed or used in the instrument called or the process called mass spectrometer. This mass spectrometer is a device that separates the charged particles, usually ions, according to their charge to the mass ratio. Means this mass spectrometer uses this concept for any charged particle. Now about cyclotron. Now this cyclotron is a machine to accelerate the charged particle. To accelerate any electron or a proton, this type of machines are used. Why it is needed to accelerate the charged particle? It is required in some places to increase the energy of the charged particle, and we know that if the velocity increases, then the kinetic energy also increases, and hence when the charged particles are accelerated, their velocity increases, and so their kinetic energy also increases. And such charged particles with increased velocity and energy can be used for various purposes. Now students, this cyclotron was invented by the scientist E. O. Lorentz and M. S. Livingstone in 1934, and they investigated the nuclear structure using this cyclotron. That means of what the nucleus is made up of, which type of particles are present in a nucleus. So that type of studies were included in this concept. Now the cyclotron uses both electric field and magnetic field. Both these fields were combined for the function of this machine. Students, here you can see a simple construction of a cyclotron. Here these two are the electromagnets which produces the magnetic field, and here there are two D-shaped discs. These are the two D-shaped discs, and a charged particle which is called source is kept here at the center, at the midpoint of the two discs, that is between the two discs. Also these two discs, they are made up of metals and they were connected by an oscillator, means an alternating electric field is produced with the help of this oscillator. Oscillating current is there like this, and so what happens, the electric field which is produced due to this oscillator between the two D-shaped discs goes on changing, plus minus like that they will change. If this disc on the left side is positive, at that time the next disc which is on the right hand side will behave as a negative plate, and so there will be electric field towards the right hand side. Within a next moment, what happens, the field changes. Now this plate becomes positive, that is on the right hand side plate, and on the left hand side plate that becomes negative, and so now the field, electric field, will be towards the left hand side. So in this way constantly the field changes. Magnetic field due to these two electromagnets remains constant. So this is a schematic diagram. Now how we can show this diagram in 2 dimension? This is 3D diagram. Now here this 2-dimensional figure of this cyclotron is shown. Once again, these are the two D-shaped metallic discs. They were connected by an oscillator, and you can see the magnetic field by dots. You can see here in a plane, in this square plane, you can see these dots are there. So these dots represents the magnetic field normally coming out of this plane. Now a charged particle is kept at this point P between the two discs. Now what happens when the switch is made on for this oscillator? If the switch is on for this oscillator, the electric field is produced between these two plates of a disc. Suppose at present this disc becomes positive on the left side, and on the right side this behaves as a negative at the same time. So there will be electric field from positive to negative in this way. Now this charged particle which is kept at point P is in the electric field, and we know that in an electric field the force will act on a charged particle. So this charged particle will start to move, but as soon as the charged particle starts moving, now this is a moving charge in a magnetic field. Initially it was stationary before the application of electric field, but when the electric field is applied, the charged particle starts moving, and now the charged particle moves, and so now this is moving charge in a magnetic field. So what happens, it will move in a curved path. So it will move in a curved path, and as soon as it completes its half circle, the field changes. Now this plate becomes negative and this plate becomes positive, and so the electric field gets reversed, And so once again, now this charged particle will attract towards the first D, that is on the left side. And so once again, it will move in a curved path with increased energy, because in an electric field, charged particle will accelerate, and acceleration means its velocity will increase, and so the radius will also increase. So once again, this curved part will increase, and when it completes half the rotation, once again what happens? Same thing, the electric field gets reversed, and so once again, when this charged particle enters to D disk 2, that is D2, once again its velocity will increase, and so the radius of the curvature will also increase, and so on. It's go on increasing, and so the path will be spiral. Now when this charged particle will move in this spiral path with increasing radius, when it reaches to the surface of the D, and another arrangement is made to deflect this charged particle. You can see this plate, blue color plate. It is a deflecting plate, and another magnetic field is applied with respect to this plate, and so what happens? This charged particle will get deflected, and it will come out from this exit point with high velocity and high energy, because if the velocity is high, its kinetic energy will be large. So with large kinetic energy, it will come out and move towards the target. So it is clear that in a cyclotron, electric field provides energy to the charged particle, while magnetic field is used to maintain its circular motion. Here, energy of charged particle increases the radius, because as the velocity increases, its radius of circular path will also increase. But students, remember, the frequency of rotation does not change, it will remain same, and so the path is spiral. That is, when the circle, radius of the circle goes on increasing, the path becomes spiral as shown in this figure. So when this charged particle moves from one D to another D, its energy goes on increasing. Next is, every time the particles moves from one D to another, it is acted upon the electric field. Here the electric field is changing, and so as it completes one rotation, the electric field also changed at the same time, and so it will attract the charged particle, and so what happens? The energy increases. Now here, to function, for the functioning of this cyclotron in proper manner, the frequency of changing electric field, that is denoted by nu A. So this frequency of changing electric field is kept equal to the frequency of this circular motion, because here the charged particle also moves in a curved path. So both these frequencies, frequency of changing electric field and the frequency of circular motion, should be equal. And when these two frequencies becomes equal, the condition is called the resonance condition. When the frequency of two systems becomes equal, we call that condition as a resonance condition, and so this frequency is called the cyclotron frequency, and this frequency is given by nu c, which is inverse of time that we have seen in our earlier topic, and that is equal to qb upon 2 pi m. So this concept is not new for you. This formula is also not new for you because we have obtained this formula earlier also. Students, you can look here that in our earlier topic we have obtained this formula for the frequency in such type of case when a charged particle is moving in a magnetic field with some velocity. Now, the increase in the kinetic energy, as we know that the kinetic energy goes on increasing when it enters from one D to another D, and that change in kinetic energy is nothing but it is Q into V. What is V? It is the voltage applied. Which voltage? As I said that changing electric field is due to that changing potential difference. Changing voltage gives the energy to the charged particle. So Q into V is that energy provided to the charged particle in a potential. We have also used this formula or obtained this formula in chapter number 2. You might have remembered. We know that U is equal to Q into V. So that energy is nothing but it is kinetic energy here. Means this energy gets converted in the kinetic energy of the charged particle. And so for one complete rotation, the periodic time is T, but the charged particle when it moves in 1D, then it will take time T by 2 in 1D. Then it moves in the another D. Once again it will take time T by 2 in another D. And so T by 2 plus T by 2 will give you periodic time T for one complete rotation. Now we know that kinetic energy is given by half mv square. Now velocity v in case of cyclotron is given by qb r upon 2m. This also we have obtained in our earlier topic. So using this velocity here we get this equation. Students, let me show you from where did we got this equation of velocity. In our earlier topic we have this equation here. You can see r is equal to mv upon qb. If we make the subject v here, then this q into b will move to the numerator, that is q b r, upon this m will move in the denominator upon m. So from this equation we obtain the velocity, and so we have kept here. Here radius of the disk, two disk, is taken as capital R, and so finally we get the kinetic energy is equal to q square b square r square upon 2m. Now where this cyclotron is used? Cyclotron is used to study the nuclear structure or nuclear reactions, because to understand the nuclear reaction, a charged particle having high velocity should enter the nucleus, and then only we can study the reactions which are occurring in the nucleus. Also, it is used to modify or synthesis new materials, because when any particle moves inside the nucleus, what happens? That element or the atom will change to some new element. Also, to produce the radioactive substances which can be used to diagnosis in the diagnosis and the treatment in hospitals. So these are some uses of the cyclotron. Now an example related to cyclotron. Here a proton is kept in a cyclotron. Cyclotron frequency is given here 10 megahertz and charge of proton 1.6 into 10 raised to minus 19 as usual. Its mass 1.67 into 10 raised to minus 27 kg. Radius of the cyclotron disk is 60 centimeter. But when we use these values to calculate, we have to keep that value in terms of SI system unit. So we have converted that into meter, so it is 0.6 meter. Here we have to calculate the energy of this proton in MeV. MeV means it is million electron volt or mega. M for mega electron volt. Mega means 10 raised to power 6. Now students, in cyclotron we know that omega is equal to QB by M. We have obtained this formula, and omega is also 2 pi nu. Now from this equation, if we make the subject B, we will get B is equal to 2 pi nu M upon QB. From this equation easily you can separate this B or make the subject B, because we want to find magnetic field also. Now all these values are given to you. So putting these values here and calculating, we get the magnetic field B is equal to 0.66 Tesla. Now magnetic field is obtained. We want to calculate now energy. Now to calculate the energy, we have to use this formula, because energy of this charged particle will be in terms of kinetic energy. So we have taken E is equal to half of mv square. We don't have this velocity. So first we will calculate the velocity and then we will put that velocity in this equation. So at present we will put this equation or give this equation number 1 so that it can be used afterwards. Now what is velocity? Velocity is distance upon time. And how much distance it will cover for one complete rotation? We know that the path is circular, so distance will be 2 pi r along the circumference of a circle. So circumference of a circle is 2 pi r. So for one complete rotation, the time taken will be periodic time t. So here velocity v is equal to 2 pi r by t. But we know that 1 upon t is nothing but it is frequency, and that's why we have written here 2 pi r into nu, because 1 by t is nothing but it is nu, frequency. Now we have all these values. We have the radius also, and we have also frequency given in the data. And so putting these values, we get velocity equal to 3.78 into 10 raised to 7 meter per second. Students, here frequency is given 10 megahertz and M means 10 raised to 6. So while putting the values, you have to remember this. Now after obtaining the velocity, putting the value of velocity in this equation number 1. Here mass is given, mass of the proton is also given, so putting these values in this equation number 1, we will get energy is equal to 11.9 into 10 raised to minus 13 joule. Joule is the SI system of unit. So energy is obtained in terms of joule. But here it is asked to obtain energy in MeV. So to convert joule to MeV, we have to use this. That is 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. And so to convert joule to electron volt, we have to divide this by 1.6 into 10 raised to minus 19. So when we divide this 11.9 into 10 raised to minus 13 joule by 1.6 into 10 raised to minus 19, we will get this answer as 7.4 into 10 raised to 6 electron volt. But what is 10 raised to 6? It is m. In place of 10 raised to 6, we can write m, that is mega. So MeV. So 7.4 MeV is the answer. I hope you understood this. If you have any doubt related to these topics, you can ask me.